So I want to talk to you briefly about schema design and the importance of it anyway. The very first of that piece, if you will, is the snowflake schema. Now remember, schemas are essentially the columns that are in the table. Right? So you have a table and you have a bunch of columns. And each of those columns have data types. Like, for example, this is an integer, let's say, and this is a variable length character, let's say, and this is a date, let's say. Right? This right over here makes up the schema. Okay? So if I said a table schema, I'm referring to the names of the columns and their data types. So when we talk about schema design, we're really talking about the fact that how those tables are put together, if you will, in a relationship. So when we discuss the snowflake schema, that basically means that we have a customers table, let's say, and the customers table has associated with it an addresses table. An addresses table is associated with it a zip code table that relates zip codes to city states. And let's say the customers table is also associated with a sales table. And the sales table is associated with the products table. And the products table is associated with the inventory table. Can you see this looking like, sort of looking like a snowflake? You see what I'm talking about here? Snowflake, the way it extends. So snowflake schema is essentially designed to support normalized table structures, where the data in the customer table only holds customer data. Address table only holds address data, and the zip codes table only holds zip codes data, and so on. And the tables are related to one another via primary and foreign keys. Essentially, the customer will have a customer ID, address will have an address ID and a customer ID, and zip codes will have a zip code ID and an address ID, and so on. The relationships are established between the tables by the use of primary and foreign keys with essentially data that is not repeating. That's the snowflake schema. Then there is the star schema. Star schema is a little bit different than the snowflake schema in that it supports fast reads, which means that it essentially has denormalized data, which is where data repeats itself. So it has this central table that is considered a fact table. And the fact table spawns outside of it these associated tables that have primary keys. So outside of the fact table, you will have the customers table and the products table and the invoices table and the sales table and so on. The fact table contains within it a bunch of foreign keys. And those foreign keys are related to the primary keys, which exists in the related tables, which essentially means that when you're doing a search, when you're doing a query against a star schema, you'll be able to get from the fact table to any of the other related tables with one hop, as it's called. And that one hop essentially means that from the fact table, you only need to jump one table or one relationship to reach the table you want. So it is meant for fast reads. The snowflake and the star schema are designed primarily for online transaction processing and online analytical processing. The snowflake schema is designed for online transaction processing, where the data is essentially written to. And star schema is written and designed for online analytical processing or for the purposes of reporting. When you're reporting on data, you need to read it fast. When you are writing data to a table, you want to be sure that the data that you're writing is not repeated in the table that you're writing it in. So OLAP versus OLTP. Read, write, and usually reporting. Star schema. Snowflake schema. And that's really the gist of schema design.